Okay, so you got a question about the scenarios, is that right?
Yeah.
Which one?
Well, you did the first page with them yesterday?
No, I just did 2 of them.
Okay. Because I've done all the A's, so I was just gonna ask if on the A's. So any of the A's you
Which one do you want me to do?
do A5.
A5, that was the one I did yesterday.
Oh,
Want to do it again?
A4.
A4, I think.
You did that one yesterday?
I did that one yesterday too.
A3.
A3. Sylvia is a medical researcher. She wants to study the metabolism rates for men and women. She decides to use couples for her comparison, divides the study where both spouses will eat the same foods because she believes. Did we put this another one that quizzes before? This sounds familiar to me.
I think it might have been on the test.
It might have been on the test, yeah. You don't remember?
A2 was on the test.
Oh, it was A2 was on the test. All right, let's see. So she's using couples for a comparison, divides the study where both spouses will eat the same foods. She believes diet has a significant effect on metabolism. She tries to pick couples where the general health of both spouses are similar. The study requires blood to be drawn after consuming caffeine in similar amounts adjusted for body mass. She has 37 couples in her study. Wants to determine if the amount of caffeine in the blood is different between men and women. 40 minutes after consuming the caffeine, she takes a blood sample from both the husband and wife and measures the caffeine still in the system. Which hypothesis test should still be used? Okay, so should we go through our steps?
Yeah.
Okay. What's our first question? Type of data, right? Categorical, quantitative, or regression. Should we vote? Who says categorical? 1. Who says it's quantitative? Bunch. Who says it's regression? Nobody? Okay, majority wins. It's quantitative. Why did you think it was categorical, Victor?
Compare.
Okay, so what are we comparing? Yeah, we're comparing caffeine, and it's going to be some sort of an amount, right? We don't know what the amount is, but it's a number. It's going to be a number, right? Yeah. Okay. All right. So now, so if you watched my video yesterday, I don't know what was easier to do. Was it the null hypothesis or was it the test? I think the test is a little easier. Okay. So let's ask: is a z, a t, a chi-square, or an f?
T.
So who says z? Nobody. Who says t? Bunch. Who says chi-square? Who says f? Okay, it's t is correct. Which t? Let's see here. Matched pairs. Let's see. Okay. Matched pairs. Does anybody disagree with that? Who disagrees? Okay. Eric's grabbing his Hartley. Man, nobody disagree with me. All right, that's correct. Okay, so now that we know it's a matched pairs T, what's the null and the alternative hypothesis? Did you say it again? D equals 0. Who agrees with her? 1, 2, 3, 4, 5. Who disagrees? Nobody disagrees? There's only 5 people. Raise your hand. More than 5 people in here. She's correct. But how come only got 5 people agreeing with me? Because the rest of you didn't know? I should have asked. Who doesn't know? Okay, all right. Yes, D is correct. And What's the alternative? D does not equal 0. Okay. Who feels comfortable making conclusions and rejections and not rejections? Or who's not comfortable? Let's ask that question. One. Okay. All right. So you get a p-value. Oh, actually, what equation should you use? You know that? The one on the equation sheet. It's going to be t equals something, right?
Equals d bar minus u
D bar,
over s.
d bar minus d over s of d. Is that it?
Square root.
The square root of s of d over the square root of n.
Square root of n.
Square root of n. Okay. All right. So we get a p-value that equals 0.98. Ramiro, reject or do not reject? P-value is 0.98. Do not reject. And therefore your conclusion is
there's not enough evidence that
a difference between. See, this one's kind of weird.
Does d equal, does d represent difference?
This one's kind of weird because it makes it sound like they want to compare the men versus the women, and they are couples, but it says that they're doing it 40 minutes after consuming the caffeine, which sounds like it's the same person twice, but they are using couples. Sounds like a really bad experiment design is what it sounds like.
Sounds like something.
Because I was trying to say between before and after, but it's probably.
question for you. Scenario type stuff is that going to be more in the written test where you do that, and then are you going to give us a p-value and then have us make a conclusion?
Yeah, I probably would do that. But having said that, yeah, this kind of thing was more likely on the written test. But if you can do this well, you won't pick the wrong test on the computer test.
Right. I'm just saying for time's sake on the written, like the end. When would you give us a p-value? Like have us write what you put.
Well, the main reason I'm giving you p-value is because some of you are still missing them. Like, I give you a p-value and then you say do not reject when you're supposed to reject, and vice versa. And if you do that wrong, and then some of you will say reject, no, which means there's a difference, and then you'll say there's not a difference. I'm like, what are you doing? You're conflicting with yourself. Covering all the bases. Yeah, that's a guaranteed wrong score. Okay. So the other thing that I try to do is, let's say you get your p-value wrong. Your conclusion will be based on whatever p-value you get. Okay. What if you get a p-value of 1.57? That's definitely wrong. Why is that definitely wrong? Can't be greater than 1. Or I love it when I get a p-value of negative 0.03. That's wrong. Why? Because it can't be less than 0. Okay. And I'll see those. And sometimes I'll get something like 2.58. And I'll be like, is that the critical value? What are you doing? But clearly you don't know what you're doing if you give me a number like that. And then I'm like, well, I don't know what to do because 2.58 doesn't even make sense. When I try to guess, do they kind of know what they're doing or do they not? I don't know. The best thing is when I get p-value equals, and then they go reject. I don't know. You didn't give me a p-value. What are you supposed to do with that? I don't know. So, anyway, I just did a 1040 exam, and that's they were doing hypothesis testing, and they only need to know 4. you guys have to know like 12. They only need to know 4. And they would not even like give me a t-score or a p-value. And then they're like, reject. I'm like, no, you don't get credit for not showing me anyway. Okay. But you guys don't do that. All right. So did you get it right?
Yeah.
Okay. Sweet.
You do one.
Fine.
So B bar is the mean of difference between the men and women. And then what's B?
Well, that's what I was saying. This one's a little confusing because they say they want to pick the men's and the women, but then they say they're doing it 40 minutes after the caffeine. So it sounds like it's a before and after.
This is from both the husband and wife.
I mean, they're giving them the caffeine at the same time. They just want to have people that have the same category.
Well, yeah, this one's not super clear because, to be honest, this is a really bad experiment design. Because it says they want to compare the men and the women, but if you're comparing the same person against themselves, if you want to see the rate that caffeine goes, I mean, if you're comparing the men and the women, that sounds like an independent test. But now they're coupled, so now you're like, well, that's dependent. But then you're doing it before and after. Well, if you're doing it before and after, you shouldn't be comparing the men and the women. You're doing the before and the after. That's why I kind of hedged a little bit on the conclusion because it's not entirely clear to me what they're doing. It's definitely a paired t-test, but I'm not 100% clear. I'd probably have to really look at the data to say, what are you really measuring here? Because to me, it looks like a before and an after, and you're comparing the person with themselves. But the question says the men versus the women. You can't compare the men versus the women if you're doing the before and the after, because now it's not independent anymore. So it does seem like a bad.
They're just testing.
No, they're doing it 40 minutes. Sounds like
They're not doing it in the beginning though. They're just doing it after.
Stupid, but they're not.
the study requires after consuming caffeine in similar amounts. Well, if you don't know if you don't have a baseline, what are you doing?
We're seeing how fast the.
It's a bad experiment design is what it is. Samantha, you had a comment, question? But they should be, because how do you know the rate that it's going down if you're not testing the before?
Because they not put in the certain.
It's a bad design. It's really a bad design. Okay.
We do one more.
Which one?
8.
8.
Yeah.
Jed is the controller for the finance department of his company. He believes that more than 10% of all invoices are filled out incorrectly. He has about 22,000 invoices from last year, and he's going to select a sample of them. Each will be audited by Jed, and he will determine if each one is correct or incorrect. If Jed wants to test his theory to see if more than 1 out of 10 invoices has an error, which hypothesis should we use? Okay, so I'll make this a little bit smaller. What's your first question? Categorical, quantitative, or regression? And are you telling me you think it's categorical?
Mm-hmm.
Who agrees with them? It's categorical. Who disagrees? Who didn't raise your hand? Liar. It's categorical. Okay. You gonna do the test or you gonna do the hypothesis? Test. Is it a Z, T, chi-square, or not?
I put chi-square goodness is 50,000.
You did chi-square goodness. Here, I'll put GOF. Okay? Who agrees with them? Chi-square goodness of fit test. That's what he's saying. Who agrees with them? 1. Who disagrees with them? 2, 3, 4. What do you think, Victor? You think it's a T? A Z? Which kind of a Z? I don't know, just a plain old Z. What do you think?
It would be a type of horseshoe.
Z1 sample, is it a proportion or a mean? Proportion. What do you think, Tyler? Same? Samantha, didn't you raise your hand?
Yeah.
Okay, so now we got 2 choices here. Let's ask that question again. Chi-square goodness of fit. Did you change your mind?
I still have no idea.
No idea? You didn't raise your hand again. You're not sticking by your guns. Who thinks it's a Z1 sample proportion? 1, 2, 3, 4, 5, 6, 7, 8. Who thinks it's something else? You should have thought it was a one sample proportion. Okay, what was the fit on that one? What are we fitting it to?
Well, my guess is that he's like to see if he's correct at 1 out of 10. So he'd be like seeing if actually.
But that's a proportion. Yeah, so it's a one, yeah. So it's a Z1 sample proportion, okay? All right, so now what's the null and the alternative hypothesis? Somebody besides Eric, he always answers. Tyler.
Good question. So if you wanted to make this into a survey test, can you do that by saying like, Jed or whoever has his file saved right in front of someone else in the office has as well, and then you have one person. So if you're running like 3 people's invoices, it's the same statistic.
Okay, so he's asking how could you turn this into a goodness of fit by comparing it with 2 other people, essentially? So no, that's not true. So if you're going to do a goodness of fit, you have to fit it against something known. Okay, so you think that there's 10% on Monday and there's 20% on Tuesday and there's 13% on Wednesday. Like I'm giving you multiple things here or something like that. You're comparing it versus these specific numbers on these specific days. That would be a goodness of fit. So you gotta, so you really, in this case, you would need more information to get a goodness of fit in here. But there's plenty of information here. I mean, this is kind of the key phrase right here. He wants to see if his theory about 1 out of 10, okay? They're giving you the proportion right there. In fact, that's the key phrase for the null hypothesis. So the null hypothesis should be, Austin, it's highlighted for you, man. You said equals 1 out of 10. What equals 1 out of 10? You wimped out on it, man. You didn't give me a letter. Okay. Which you're going to know the letter on the test, right? Okay. What letter should you use? Huh? After this one. What letter should you use? P or P hat? No. P. You should never use P hat. Why should you never use P hat?
You're making an assumption of the population.
Yeah, and P hat is the, no, it's the sample. Yeah, P is the population, P hat's the sample. It's always about the population. Okay? All right, and so your alternative hypothesis is P, let's see. What does he believe? Is it not equal to? More than. He thinks it's more than 10%. So it's not equal to, it's more than 1 out of 10 or 10%. Okay? Do I care whether you use a fraction or decimal on that?
No.
Either one's fine. Okay? All right. Let's see. Do you know the equation? Will you be able to look at it? Will you be able to find it if I give you the formula sheet?
Yeah.
Okay, I hope so. So you get a p-value equal to 0.04. So Alex, what do? You're going to reject, which means can't hear you. Still can't hear
Is it greater than 1 out of 10?
you. There is evidence that portion of invoices incorrect is greater than 1 out of 10. Who agrees with that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who disagrees? You should have agreed. Okay. All right. So you ready? How'd you do? Did you get that one right?
I did wrong.
You didn't do well on that
I
one.
did really wrong.
Okay. 50%, yeah. I'll bump that up a little bit. All right, so you're gonna do good on my quiz now?
Hopefully,
How much time do you want for your quiz? Let me ask it that way.
I'd rather just practice.
I know. I'll let you practice on the quiz.
1 minute.
See how good you do. All right, let's do that. I'll just hit pause on this, and we'll continue on after the quiz. Pause. Okay, so what do you guys want to talk about now? Yes.
Could we do like a speed round with the scenarios?
A speed round. You just want me to blow through them?
Yeah, blow through them and just like name what test we're using.
You don't want me to go through all the other stuff?
No.
Okay.
B1,
You want to start with B1?
You just go down the line.
We got to get as many right answers before we take our quiz tomorrow, right? Is that the
I
idea?
just want to actually have an answer key to base on what we're doing.
All right, let's look at B1. USDA has commissioned a study to determine the relative yield of 2 different soybeans. Acquired 38 plots of land in 6 different Midwestern states. Oh, this one is a tricky one. So anyway, just keep in mind. This one is intended to be tricky though. The other one wasn't. Covering several different types of terrain. Each plot is 20 acres. In each plot, they will use half of the land to plant the bean A and the other half to plant bean B. At the end of the growing season, the beans will be harvested and will be measured in pounds per acre. They want to compare 2 yields to see which bean produces the best, which hypothesis this. Okay? So let's do, so we'll do this quickly. Categorical or quantitative or regression? Definitely quantitative. Oh, sorry. I thought I was on the board. Oh, are we sharing? Yeah, we are sharing. Okay, it's quantitative and then kind of a test.
Match pair.
Match pair. It's in 6 different Midwestern states.
Dependent.
Z dependent. Chi-square goodness of fit. I'm going to just abbreviate it that way. Any other ideas?
Which one?
Huh? Nobody said ANOVA? I thought for sure somebody would say ANOVA. Here, I'm going to throw that out there. I'm not speeding through this, but anyway, I'm going to give you 4 choices on that one. Those are the 4 most common choices. Who thinks it's matched pair? 1. Who thinks it's Z dependent? Nobody? Who thinks it's chi-square goodness of fit? 1, 2, 3, 4, 5. Who thinks it's ANOVA? 1, 2, 3, 4. Who doesn't know? Okay, that was the best answer right there. It was matched pair. Planting half of it on it, half was bean A, half is bean B. We're matching each plot with half. Okay, does that make sense?
Yeah.
Okay. All right, we'll speed through these. Market research companies have been asked to find the preference between 2 brands of power tools. Their data from the last survey indicated Hefty were preferred by 64, where Skillcraft were 36. Previous survey 4 years ago found that they only surveyed men 25 to 54. They want to do a new survey, but this time they want to pull both men and women in that same age range. They must self-identify as hand tool users. The pertinent question asks, which manufacturer's hand tools do you prefer, Hefty or Skillcraft? Which hypothesis test should they use? So, oh, are we out of time? Okay, we'll finish on this one. Categorical or quantitative? Categorical, what kind of a test? Z, what'd you say?
Dependent sample. Two proportions.
No, it's a one sample proportion. Okay? I didn't realize we're out of time. Okay? Yeah, people miss that one all the time too. Z1 sample, where you can either pick the 36 or the 64, and then you're comparing the other group to whatever number you picked. Okay? All right. See y'all tomorrow. Where was your speed round?